it's anyway, to say. Oh, by the way, today's joke might be my favorite joke of the year. It might be. Okay. So, as you wrote, power is a calculation that researchers like to make before doing a hypothesis test to see if it's worth doing. I want you to imagine, like, attorneys are in a meeting and they have all their evidence and they're sort of deciding whether or not to take a case to trial. They're basically like seeing the weight of the evidence. Don't you think it would be worth it? I think that happens a lot actually in the legal system. That's where you end up with like plea bargains and things because they're like, we just don't think we have enough evidence to like make a whole big trial out of this. And so, but power is actually a calculation that we will not be doing. And that's the part where I said, don't freak out because I feel like people want the backstory and we don't need the backstory. College Board, your book, AP Classroom will never ask you to calculate power. It's really complicated. There's like overlapping normal curves and it's like an area. And if you're interested, you can definitely YouTube it. I watched one last night and I was like, is it worth even showing this to them? And I was like, nope, no, 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 no. If they're interested, you can definitely YouTube it, but like you're never going to be asked to calculate it. So we just kind of need to know what it is. Okay, so power is, it's your favorite thing. It's a conditional probability. I know, it's not your favorite thing. Okay, what is a conditional probability? Thinking back to chapter 5. It's the probability of something happening given that something else already happened. So it's one of the ones that has given in it. Okay, so power is the probability you will find convincing evidence for the ha. That's what you want, right? It's a probability that you'll find someone guilty. Reject the hoe. And that's the next thing we're going to put. And remember, I said rejecting the hoe is what we're after. That's what we want to do. That means we discovered something because we're prosecutors in this situation. So power is the conditional probability. It's the probability that we win. We have convincing evidence for the ha. But remember, it's conditional, comma, given the ha is actually true. Meaning that you're not just rejecting the hoe because of a type 1 error. Means you're appropriately rejecting the hoe. You're appropriately finding convincing evidence. And that's, I mean, does that make sense? That's what you would want to find out, right? So if we talk about this in a court case, it's a probability that you'll find someone guilty given that they're actually guilty. That's kind of the goal. Okay. Now, we're going to bring this to a simpler definition. It's basically the probability you don't commit a type 2 error. And to be honest, you could boil this whole lesson down to that sentence. If you can remember, power is the probability that you won't commit a type 2 error because we're going to put that into a math formula in about 2 seconds, which is the only math formula I'm going to expect you to remember from this section. But okay. Now, would it make sense that you would want to have more power? Okay, now let me just ask you, power is a positive word in this case. Please don't think about, don't put your coin hat on right now. Now's not the time to go like, power is evil. Like, no, you, you want, this is like an engineering power. Like you want more power. Okay, so power is a good thing. It means you're actually finding something that's worth finding. Okay, anyway, I just wanted to say coin hat, by the way. Power can be increased by, so you want to increase power, that's a good thing. So I'm going to just put a little smiley here. Power can be increased by, oh, by the way, this seems to be the theme of every single thing in this class, but increasing sample size. You have more evidence if your sample is bigger. Okay, another way is to increase alpha, which is kind of a shadier way. That makes it easier to reject the hoe. However, that gives you an easier chance of committing a type 1 error if you do that. So that's not really great. If you adjust the boundary, we've talked about the fact that you probably shouldn't retroactively adjust the boundary to what you want it to be. Okay. And the last one is your is your parameter and sample values are farther apart. Okay, and that's also kind of shady. So write that down and then I'll talk about those things. The first one's really the only good idea. And then I'm going to bring it back to Bernardo. I didn't bring Bernardo today. I brought him home because people were messing with him. No, like math 3, sophomore boy. Then he touched the floor a couple of times, and then I was like, that's it, he's going home.
No.
Okay. So let's talk about this. Power is good in this case. It's not like, power over human beings in history. That's not what we're talking about here. We're talking about, you're more sure about rejecting the null. How about you're going into your court case with so many files, you're confident, you have more power. You're like, yep, I got this one in the bag. That's what you're thinking. You want to be more confident. You don't want to be nervous about whether or not you're going to find them guilty. Okay. Well, how can you do that? The best way, the most ethical way is to increase the sample size so that you're more sure about having more evidence. Okay. You could increase alpha. Doing that after the fact is a bad idea because if you just move it to get the results you want, that's why people say that, statistics can be manipulated. That's a way to manipulate it to where you want You want to, Okay, but then if you do that, you increase your chance of type 1 error, which might be bad, especially in a criminal case. And then what I mean by this is your parameter and sample values are so far apart that that you can be really sure. Now, this is what I want to bring back for Bernardo. So remember, he said he was an 80% trash ball shooter, right? But his sample was bad, real bad. And so when you looked at that, you're like, oh, his sample was so far into the tail that I can be really sure that he's not an 80% shooter. Do you see what I mean? Like his sample was so far off of what the parameter was, 64 versus 80. You can actually look at that at the beginning before you do the test and be like, dude, 64 is really far from 80. I'm going to have a really big z-score, which means I'm going to be able to reject the null hypothesis. So that's what I mean by that. And if you were to use this bullet point, what that would mean would be that you would have to, this is terrible, but you didn't get the sample you wanted, so you'd have to redo the sampling process to get one to manipulate it the way you wanted it to be. Like, oh, Bernardo, that sample's too close to 80%. So I'm going to have you go shoot again. I'm going to have you go shoot again. I'm going to have you go shoot again until I get what I want. Also not a great idea. But anyway, those are ways. I mean, I'm not lying. Those are ways to increase your power. Be more sure about rejecting the hypothesis. Okay. Now, I know that we have had some vocab. What we're going to do next is I'm going to make you a little arrow diagram in this space here that is going to relate how things affect each other. Okay, so increasing power, that's a good thing, right? So as we go up, how can I increase power? If I want to increase power, I could increase alpha. Power and alpha go in the same direction. If you increase alpha, you increase power. Sample size and power go in the same direction. If you increase sample size, you increase power. But if you increase alpha and you increase power, you also increase the chance of a type 1 error. Now, real quick, do you guys remember what the probability of a type 1 error is? You don't probably. We talked about it like for a hot second. Let me flip back. Remember, if we're 90% confident in something, we expect to be wrong 10% of the time. So probability of type 1 error is whatever alpha is. I'm going to write that again in a second. Okay. However, and this is what I said, you could basically boil this whole lesson down to one thing. The probability that you don't commit a type 2 error is power. So probability of type 2 and type 1 have an inverse relationship. So he's the only one that doesn't go in the same direction. So when you're working on things, you're doing problems, you're writing things, they're asking you about power, everything goes in the same direction except type 2, because type 1 and 2 are inverses of each other. So he's the only one that doesn't play nice with everybody else. Okay. Now we're going to write a sentence. We're going to do a quick example. Am I going to make it in 9 minutes? I'm hoping to. highlighting that obnoxiously because you're going to look for the interpretation thing later, probably. Does everybody have my arrow diagram? Not you. Does everybody have my arrow diagram? Okay. Okay. Interpreting power. If the true proportion, the true mean of whatever is in the problem is something, and they're going to give you a number that is associated with the power that they gave you. Again, you're never going to have to calculate that all year. Never. Not going to do it. They're just going to give it to you. It's just too hard. But we all have software. Just want you to rest assured. Stat software that like actual adults use when they're doing research will give you the power immediately. You will not need to crank out your TI-84 for that. Okay, if the true context is P equals or mu equals, there is a it's not a bad sentence even. Um, I'm just going to tell you right now, do not put this in your short-term memory at the moment. Wait till after the chapter 8 test, and then you can start working on this one. Okay, so interpret the power of the test. Okay. Back to the AAA batteries from section 9.1. The power of the test to detect 31 hours of you guys remember it was like mean lifetime of the batteries is 76.2%, which means this has got 76.2% power. How do you feel about that? Your 76.2% power as you're walking into the courtroom. Pretty good, pretty good. I don't know. I don't think we can look at it like grades. I don't know. For me, I immediately make that a C in my mind, and I'm like, that's bad, but that's not how that works. So, anyway, okay. If the true mean lifetime of the AAA batteries is mu equals 31 hours, comma, there is a 0.762 probability conveying is not a word as far as I know. We should make it a word. Okay, what was the alternative hypothesis for the batteries? After you get this written, flip back into your 9.1, find the batteries example. See if we can find the alternative hypothesis for the batteries. Holy spicoli, it's a what? Oh, here we go. Greater than 30. Okay, so if the true mean lifetime of the batteries is actually something that's greater than 30, that means it's good, right? Batteries are good. There's 76.2% probability of getting a sample that will give you convincing evidence that it's actually greater than 30. So you have less of a chance to get a wonky sample that will tell you that it's less than 30 when it's not. Okay. Two more things and then we're done. How much? Oh, I have 1 minute in my own timeline. Okay. Find the probability of the type 1 error and probability of type 2 error. This is the fastest math I'm ever going to do. So I put a box around that because it's kind of buried in your other notes. Probability of type 1 error is alpha. What was alpha in this battery problem? Zero 0.05, which is nice middle of the route. Okay. Now, I said up here that power was basically the probability that you don't commit a type 2 error, which means they're complements of each other. So probability of type 2 is 1 minus power. That's really the only math you need to do on these problems. You need to find alpha, and then you need to do 1 minus whatever decimal they give you for power. That's really the extent of it. Do you guys see where I got the 0.762 from though? Those problems are my favorite. They are just my favorite. You get a number from a problem, and then you subtract a different number from one, and it's glorious. Okay, anyway, describe 2 ways. Wait, Mrs. Talbot, you got 3 bullet points. I know, I added an extra bullet point. Okay, so what is the way we should increase the power of the test? What would be the ethical best practice way to increase power? Increase samples. Okay, and what's a shadier way that we could increase power? For example, 0.05 to 0.10, which is really your only option because we only use 3 in this class. Okay, and what's the even shadier way? Yeah, so get a sample that's above 30, like farther above 30 than 31. So if it was even greater than that, you could more and more easily say that it's above 30. I'm done. Except I have to show you my favorite joke of the year. I would love it if you'd spend the rest of the period working on your MCQ. That would make me super happy. And if you come across anything that you want to ask me about, please do while you're here in my presence. Unless you already did your MCQs a week ago, but it would be, well, oh, I'm not calling anyone out here. It's fine. Just do anything you like then. But let me show you my joke. It's amazing and highly inappropriate, but still worth it. Yeah. I did not make this. I found it on Pinterest and it was the best day of my life. You're never gonna forget now. You're taking the test, which is really far from now, and you're gonna be like, yeah, Snoop is telling me that I must reject the hoe. So, oh, real quick, 2 things, very important things. First, this homework is not due till Friday. Only the MCQs are due tomorrow. Second, tomorrow is the deadline for any late or absent chapter 8 work, not 9, just the old chapter 8 stuff. Does that make sense? So tomorrow, the only thing I'll want to stamp is anything that you have left over from chapter 8, if there's anything. And I can stamp your MCQ box if you want. Okay, so you like the joke?